this talk that's dedicated, I'm proud to do so, is dedicated to Tchavdar, who has played a significant part in my life over that last 8 years. And it's a pleasure to be here, and I'm grateful for being invited to contribute to this special session. There is a very specific connection between my talk and the last one. We had a little bit of liaison beforehand about who was going to talk about what, but I will be unable to answer any of the questions that you put to Dorothy. So that's the first thing I should make clear. Just one particular component of this talk that I want to elaborate upon, and I hope it's of some interest. The other thing I should say at the beginning is that I have some trouble with my left-foot leading slides here. It's not a political movement, but you'll see the margin on the left has disappeared. I apologize for that. I hope none of the formerly disappeared. Okay. Well, I first met Tchavdar. He doesn't actually remember this, I think. But I first met him in Bregenz in Austria at a conference on symmetries in science. I certainly remember his talk. He doesn't remember mine, I guess. But, that's the first time our paths crossed, and then we met successively at the group theoretical methods conferences in Moscow, 1990, where he does remember meeting me, I think, and then Salamanca, and then Goslar. And serendipity plays a part in all our lives. I was in Brisbane in 2000, and my visit there overlapped, I think, for 3 days with Nelly's very long. And at the end of one of a telephone line was Tchavdar, and as an outcome of that, within those 3 days, we formulated an application to the Royal Society for a UK-Bulgarian joint project grant. And it was on the basis of that that we had many collaborative visits in both directions, and I'm grateful for that being done. And I have to say, if Nelly hadn't stood over me and forced me to fill in my parts of the form, this would probably never have happened. And she was very persuasive, and I guess Tchavdar was very persuasive at the other end of the telephone line as well. I don't think we spoke at that time, but we were putting together this application. So we had 2 exchange visits in each direction, and then, unfortunately, I've only met Tchavdar twice more, thanks to Dobrak here in 2005, and now again at this meeting here. So that's the background to our interaction, and that's the reason I guess I'm speaking here rather than some of you who probably know much better than I do and for much a longer period of time. Well, he introduced me. What are the outcomes? He introduced me to these Wigner quantum systems that you've heard about, in particular the n-particle 3-dimensional Wigner quantum oscillator. Tchavdar and Nelly taught me about parallel boson operators, non-commutative geometry, Fock space, universe of lucid algebras, and we had some interesting discussions actually about one of the questions that you asked about these uncertainty principles with respect to quartet measurements. And we had some interesting discussions about whether the particle was sitting in this nest or that nest, or how it jumped from one to the other. So we'd had a lot of discussion on this non-commutative geometry, but I came at it from a very naive. I was a physicist so many years ago I've almost forgotten. Tchavdar had great insight, I thought, at the time about how to interpret these mathematical models. My interest was in the mathematics, but the interpretation was very much in his hands. And he led me into these very interesting areas. They also helped me renew my interaction with Joris, whom actually had been a postdoc of mine many years back ago out in Southamption. But we renewed our interaction as a result of this particular link. And the concrete outcome was joint papers, conference publications, and so on. My impressions of Tchavdar, he was immensely stimulating. Throughout the time I was with him, full of ideas, and a great determination to pursue ideas to their limits somehow. It doesn't, I think Mr. Todorov said, he comes up with an interesting observation. You don't just play with it, you work hard at it to see what it gives you. And that was one of his characteristics. His breadth of knowledge, attention to detail, which is part of that philosophy, but above all, he was great fun to work with. I mean, if you choose a collaborator, you want someone you can enjoy being with. And in this case, it worked, for me at least, extremely well. I want to talk about an unexpected outcome. This was not predictable at the start. I had a background in combinatorics, really, of young tableau and the like, and had some knowledge of least superalgebra representations and so on. But one thing I would not have predicted of the outcome is the problem I'm going to talk about. I received a query from Joris, who was working with Steve Levens and Nelly. They were studying these paraboson representations of these superalgebras in this OSP 1-2n. It's using precisely Ganchev and Palev's formalism. And they identified these Fox-based modules, which Joris has already mentioned. I call them V bar P, for any P in any integer P. And they constructed these unitary, irreducible, infinite dimensional representations. Although I was brought up in physics, the unitarity of a representation initially didn't worry me very much. But here it clearly played an important role. And we wanted to get to the irreducible, so you have to quotient out the maximal submodule, and you found for P greater than or equal to n, this is the Varna module, and it is irreducible. But the interesting cases were for P is less than n, and we do have to do this factorization, but these guys were clever enough to calculate the characters in both cases, both situations.
Is P running through a real variable?
In my talk it will be an integer, a positive integer. But there are representations for which P can take on any real value.
But you have a line and you have a unit along that line.
Yes.
Okay, I just wondered.
Yes, yes.
And it's a maximal parabolic going on here.
I'm not sure what's
Well,
there is a maximal parabolic.
Yeah, yes. It's the parameter that occurs in a maximal parabolic.
No,
The one-dimensional. It's the one-dimensional center of the Levy factor of parabolic.
I'm not sure that that's the right way to look at it. Well, I'm looking at a representation, explicit representation of this.
You induce from a one-dimensional.
No, it comes from the universal curve. You see, you have ISO2, which is like the universal curve, and this is the energy, so to say. So above the threshold, you can take any energy. And then the threshold, then starts from discrete value.
I hope it's quite clear. This was the character that they calculated for all positive integers P, and the significant part of this statement is that it involves this sum over Schur functions that's specified by the partitions lambda, for which the length of lambda is less than or equal to P. So it's this object here which is the combinatorialist interest. I wasn't particularly interested in where it came from, but that object itself was of interest. And the conjecture that was sent to me was this one, that if you take this sum of the Schur functions, you can express it in this form with this denominator factor, which we've already seen at least twice now in Popov's talk. This is to do with the cohomology of the complex that he was talking about in his exposition. So this was a fairly familiar looking object, and is very well known and crops up in lots of places when you're generating series of Schur functions. But this numerator was the odd thing. And the numerator is the sum over all partitions eta, which in Frobenius notation take this particular form. And I'll tell you what Frobenius notation is and what this means in a moment, but this was the expression as it came to me with these particular sign factors, plus or minus 1 here. So an alternating sequence of these. And this, if we ignore this and put 1, this is the generating function for all Schur functions, whatever their length. So it's this factor here which causes the truncation, which limits the length of L.